Oh, Laura's on. What size, Laura? Everyone's in the middle. Okay. We're trying to help out on a trig, arc trig, because the first thing I heard when you guys came in was homework. So then I asked, and Emma answered arc trig trig. Doesn't mean it wasn't difficult anywhere else, but let's start there. So helping us on these 47s and beyond, and you guys, thanks. Let me introduce the video. Here we go. I gave a hint of, let's not use a 3, 4, 5. Let's make a 7-11 triangle, just because whenever an arc trig has an argument, aka the input to an arc trig is a ratio of sides of a triangle. We're going backwards from ratios to angles. And if you just know the unit circle, you might not have a context of who is what or what is who when we say things like pi over 4 or root 3 over 2. So yesterday at the beginning of class, that whole you guys making unit circle quizzes, you had to be putting angles with trig, and I was answering ratios, and then I flipped the tables on you, and I said, my turn to ask you questions, and I was giving you trig inverse. Arc trig is a synonymous way of saying inverse. And I was giving you ratios and seeing if you could give me angles. That's how arc trig works. So, why did I put 7 here and not down here? Because it says sine, and sine is? Yeah. You guys are giving good answers. I'm just regurgitating it so the rest of the class can hear. But yeah, 7 is an opposite, and so I write it in the opposite side. And then 11 is the hypotenuse, I put it in the hypotenuse side. But what should you all have been doing? Pythagorean theorem, which would have said 121 minus 49, right? C squared minus B squared equals A squared. Now, if you need to, could you have written that out? Of course you could have. And you could have said something like, I don't know him, but I do know him and him. And remember, hypotenuse always goes in the C spot. So what's 122 minus, 121 minus 49? 72. Oh, doesn't 4 go into that? 18 times? Ooh, a 9 goes into that. 36 goes in twice. 6 for 2. Any of you guys struggle with rationalizing radicals? I should say simplifying radicals. So then, great, sweet, triangle. But what's the actual answer, solution to this problem? Not the triangle. Tan. It's asking for tangent of PEMDAS. You do the inside first. I analyzed the information on the inside. I used it to get a triangle. Why did I get a triangle? Because I need tangent. Oh, well that's easy. Tangent's opposite over adjacent, right? So look at your triangle. What does tangent opposite over adjacent get us? If you guys are super snazzy, yes, you could have changed that to make it all prim and proper. In Precalc, we try to stay prim and proper a little bit longer. So 7 root 2 all over 12.
Could we keep it radical 72? Yes, and keep it 7 radical 72 over 72.
The problem is it wouldn't be. I'm trying to train you guys in Precalc, to be honest. As far as the actual multiple choice matching is not near as hard as calculus. As far as you have an answer, I need to circle the right multiple choice. Yes, Nathan, you could have had rad 72 over 72. The problem is there would have been some simplifying that would have been done to get the right answer in that multiple choice selection. That kind of makes sense. But yeah, you're right as far as the quantity. Well, first of all, pause. There were some homework problems like this. Any questions you guys want to ask? It's a trig of an arc trig. These are ratios. Make a triangle. Use the triangle to answer the question. Okay-ish? Okay, so what if it's now arc trig of trig? Do you guys remember me telling Justin, nope, sorry, I wish it was true yesterday? He saw a trig with an arc trig. I forget what it was yesterday. Was it this kind? I think it was this kind. It was an angle. And I said, nah, he went in and he got changed when he came out. I don't know why, like prison analogies are just kind of coming in my head right now. But anyway, trig is not prison. Some of you would disagree with that. Like you go in and it just changes you. Anyway. some people go in and get changed and some people don't. I mean, some angles go in and get changed and some angles don't. Why is he going to get changed? Okay, tangent, but that's not actually why he's going to get changed. It's not the tan that does the changing. It's the arc. Sometimes it's not the inside that changes, but actually, I'm just going to stop the analogy, but there is a way of tying it. There's just nothing. Sometimes it's society's view, not. Okay. Why is the arc? Why is the arc? If you think about like how war changes soldiers, it's kind of might not be at the war. It's okay, so you're just going to be annoyed either way. But it might be the people's whose perspective is looking on the outside. But coming back, why is this guy the finicky one, not this one? Why is the arc or the inverse always the one that's going to be doing the changing? Not this one. I was on that big old board yesterday, and things were crossed out because they weren't acceptable. They weren't the right ones. Remember? There are restrictions. Isn't that a vocab? Justin, it was one of the vocabs, wasn't it? Something about if it's non-restricted or not restricted. Was that number 4? I love that you brought it up yesterday because I wouldn't have known that it was in homework otherwise. Something about without restrictions, there will be no blank functions. Without restrictions, inverse trig functions are impossible because they'll fail the vertical line test every time. And poor little calculator that says, I need a function that only has one answer is not going to be able to work. We have to restrict in order for this guy to be a function and in order for there to be one and only one answer. So the problem is this the one and only one answer that it would say is acceptable? He would have been one of the crossed out ones. He would have been one of the crossed out ones on the board. Does anybody remember why 5 pi over 4 isn't going to be a good one? There's an easier, smaller, more positive. Yeah, you're thinking through. 5 pi over 4, where is he? Isn't he like third quadrant? What about 1 and 2? There's bound to be a -1, +1 somewhere earlier. So 5 pi over 4 is not possibly going to be an answer. Now, some of you are seeing that the cosine with the tangent, okay, we have some issues. And you're right. And you're right, we have some issues. Or do we? What would tangent of 5 pi over 4? Somebody had to go think into the unit circle. What would that be? 1. Oh. Huh. Wait. Am I going to get... If this doesn't match with that, you're right. I can't just cross out and say 5 pi over 4 anyway. But 5 pi over 4, if this was cosine, I still couldn't cross out because this guy's gone in and he's going to get changed before it comes out because he says, I only have certain acceptable answers. Conforming? Anyway, not conformity, not today. But this one's even crazier because am I even going to land at the exact same angle? Is cosine 1 at 5 pi over 4? Oh. Whew. Okay, where is cosine 1? Why am I saying where is cosine 1? Because I'm going backwards to get an angle from a ratio. 2 pi or 2 pi is way too big. 0 or pi or 2 pi, but 0 would be the principal one. 10, 7. Wait a minute, at pi it's -1. Sorry. I know. It's -1. My cord went missing. If you wouldn't mind, whoever that was at some point texting or asking where my cord went. Okay, coming back. Left my room for like 10 minutes. Okay, so this is an angle. I could say 0 degrees or I could say 0 radians. I just don't want you guys to think that it's like a unit circle 0. Huh? Oh, I thought you heard my name. I heard someone say something. Anyway, okay, here we go. Let's go check our homework. Section 4 point, where are we at? And when does the chapter end? You guys saw me scroll to the very end of 8. Oh, that's not what we want. What do we want? Which one is your correct assignment, guys? There's... Is it this one? Or is it...
It was supposed to be in 2 parts, but wasn't.
Oh, the 2-part but wasn't one?
Yeah.
And it was all the problems, right?
Yep.
No, you're good. Calm down, take a breath. It's the right one, right?
No.
It's the left one?
Yeah.
I have no idea.
It's 42.
Did you have 108?
Oh,
And 111?
The left one.
Okay, so it's this.
Yeah.
Oh, I need to make it big, sorry.
That's
Oh.
what I copied.
This is the left. Yeah, we didn't have one.
Can I check Google Classroom on the phone?
Yeah. Hold up and see where we're at. I just want to make sure I have enough answers. Maybe I have even too many, but I want to make sure I at least have the even set.
We have the one on the left, but the
A little bit of both.
we have the one on the left, but the crossed out one.
The right one's like different?
Yes. The right one's missing more of the.
Oh, okay.
This is the assignment I was posted.
Okay. Let me know if you guys are missing anything. We'll just go for it. Let me know if you guys are missing any evens. We have 1 and 2 and 3 and 4 was an inverse. 2 was just showing that notation, which hopefully wasn't too bad because hopefully you were able to just write it down. Write it down, put it in notes. Pi over 4 was number 3. This one was a plug and chug to your calculator, and they used radian mode. Number 40 was unit circle. Did you pick the right one? What are you missing? 16. Okay. I'll freeze the screen so you guys can grade these 3. I think yesterday it was technically saying usually you can be either, if I remember right.
But for 40, that means you get like totally different answers, depending on the mode. Because I mean 26. Because I used degree mode and I got 87.71.
Nikki, to address your question, I'm going to have to look at it. Give me 1 sec. Number 16, right, Emma? Let me go ahead and let you guys look at number 16, although it was a quick one. 16 is pi over 4. Any other ones that we missed along the way? Getting to number 42, I think is going to be that. No, we're okay? So then, Nikki, your question was?
26.
Oh, 46?
26. So you could be in either mode.
There are 2 comparable answers. So the radian one is acceptable, but go ahead. Let's go ahead and check the degree one. What'd you get for your degree one?
87.79.
Cool thing is, I just heard other people say the exact same thing, so I'm betting that in degree mode you're okay. If you are on a multiple choice quiz, could you look at the answers and see if they have degree marks or not? Is that cool? It's going to have to be that switching back and forth. But no, you're right. You were right. Are we good in the rest of it? If you guys are wondering how this function was made, you had an adjacent and you had a hypotenuse. Cosine was the most appropriate function that uses adjacent and hypotenuse. You could do secant, but it chooses to do secant, which would be x over 4. And then how do you get theta alone? I believe the direction said something like get theta as a function of. That means get it by itself. How do you undo a COS? Divide by cos means nothing. Undo with an inverse or an arc. So you could have done cosine with a -1. The cosine inverse notation, that's also correct.
I don't understand 40.
Oh, you're going backwards, kid. So remember how you asked me how to do tangent inverse of root 3 over 3? Cosine of pi over 6. Can you pause until I go with the book, and then we can look at the actual problem? Because I'm just saying, go backwards, and all of a sudden there's a normal trig, which is throwing me off as far as what I was asking. So hold on. 40, right? Number 52. Number 54. Oh, here's that cool 4 over 5, so you make a triangle, and then secant is what? Hypotenuse over adjacent? Booyah. That's like how we started class. And this just told me go to the first quadrant and not go to some other quadrant where sine is positive like the second. This guy, he came in and he got changed. Why? They were both cosines. They kind of cancel out. But this would not be one of those acceptable forms. So therefore, go in, come out changed. Pi over 2 is at the exact same location as 7 pi over 2. Right? 1, 3, 5, 7. No, it's not at the same location. That's even harder. 7 pi over 2 is right here when cosine is 0. So why not do negative pi over 2? Well, the problem is to get to negative pi over 2 for a cosine, you're repeating that first quadrant positive angles. For arc cosine, we're allowed to look in quadrant 1 and in quadrant 2 where cosine is positive and negative. We wouldn't go through positives again to get that angle value. We would instead say, I know someplace cosine is 0, and that someplace is a legal angle of pi over 2. If you don't have a very deep understanding of this, it probably didn't confuse you in the sense that you're like, whatever, 0, great. Maybe you can plug it into your calculator. But if you do have a deep understanding, you might have been confused as to why it was a different location. But this location is not legal. Oh, that's cool. This location is not legal for arc cosine. If you need to, you can always memorize arc cosine only gives me answers between 0 and pi. So, negative pi over 2, 3 pi over 2, all of those are illegal. I feel like we skipped some evens. Did we skip some evens? I have 104 being the next one. 60 what? Okay, 66. After 66, what do we got? Okay. 66 was one of those like, great. We have opposite over adjacent. Opposite is x. Adjacent is, well, anything can be over 1. And the Pythagorean theorem says a squared plus b squared is c squared. Sine is opposite over hypotenuse.
Wouldn't you have to rationalize that? Or do you not want to?
Yes. Technically not simpler to rationalize it, but yes, based on all of your math training up until this point, you could do x squared root of all over x squared plus 1. In calculus, we're going to be like, ain't nobody got 9. And then 102. Negative pi over 2. Any other evens? Besides, whatever that one. Nope. Okay, let's go back to our answer key. And we have wrong answer key. 104. Okay, I have Nikki's number 40 that she wants us to look at. Do you guys have any other problems that you want us to look at besides number 40? Griffin.
45.
45. Anything else besides 40 and 45? Going once. Going twice. So, wrong one. Number 40 is a weird one because it gives you a graph. But in some ways, by the holes that they left, they kind of gave you hints and reminders as to what this arc cosine dude does. He says, I'll give you angles in the y position, so I need an angle and an angle, and I'm going to give you ratios in the x position. So, pi over 6. When or what, I should say. What is cosine at pi over 6? 1, 2, 3, 3, 2, 1. Square root of 3 over 2. I'm doing the cheater chart. You could also do the unit circle, and that pi over 6 cosine is the long one, 3 over 2, if you're a unit circle type person. Sorry, that's a 3. Looks like a 2. Anyway, I'm making it worse. But over here, I already have the ratio. I need the angle. Now, some of you might be kind of looking and say, okay, well, that's pi over 4. That's pi. This must be pi over 2. Maybe you were eyeballing it and trying to kind of figure out what it was just looking at it. This is something a little bit past pi over 2, so something in the second quadrant. A little bit past, that's probably a pi over 3. Maybe you would go, 2 pi over 3, second quadrant. Maybe you would go and double check in your unit circle. Maybe you would double check in your cheater chart. But yes, indeed, cosine is negative 1/2 there. Got him. And then cosine is negative 1 at, oh, hey, look, it's pi. So you could be looking at the graph, or you could be thinking the forwards, backwards. Kind of see it?
Yeah.
So you have angles, and then those are the y's, and then you have the x's being what cosine is there. And then number 45, I think, Griffin, that's that triangle one, right? Okay. And it gives us all kinds of x's, which are kind of weird. So in this one, I think we're just trying to solve for x. Oh, right, theta as a function for x. So in all of these, the key is what sides did they label? You guys, what sides did they label? This is the adjacent, and this is the hypotenuse. So what trig function does hypotenuse and adjacent? Secant. Yeah, please, cosine. So much easier. Cosine of theta equals adjacent over. So the key is who are the sides, and so katoa, which trig function gets me an answer for those. So cosine of theta gives me adjacent over hypotenuse, but they say get theta as a function of, that means get it alone. And the book probably used arc just because, I don't know, for some reason they seem to have a preference with the arc trig. You could have just used the good old-fashioned inverse. That's the only way to get rid of undo a trig. I think Rick can hear you all stuff. Is that cool? Okay, we said that there are 8 sections in chapter 4, and we just went over 4.7, which means we have one more. So you guys weren't 2 different homeworks, it was just one, and it was homework number, was it 30?
Yes.
I don't know what to make it. Here you go. 30 something.
4.7 was 30.
Okay. 4.8, here we go. And I go back and make it 30 because I think we came to a consensus of what it should be. 31 is the one due on Monday, which is on section 4.8. I'm going to pull it up and make sure that I want to give you as many problems as are on there right now. Ooh, that sounds interesting. All right, you guys are starting applications of, isn't that something that we had in chapter 3 with exponential and logs? Didn't we have an application section? Huh. And section, or chapter 1, section 1.10, mathematical models, I think we had an application section. They like putting these application sections at the end. The bad thing about application sections is there are word problems somewhere. The good thing about application sections is they probably are showing me more than I really need to totally perfectly know right now, because it's exposing us to what's to come. Maybe not in this class, maybe just in other classes. And maybe you'll only see 1 or 2 of the things that are in there ever again. So in some ways they're nice, in some ways they're overwhelming. But the nice thing is, guys, we've been solving for missing pieces in triangles for quite a few sections now. We've been solving for missing pieces in triangles for quite a few sections now, so maybe it won't be quite so new or crazy as some of the other application sections have been. Not near as involved as the exponential log one, I promise. Okay, looking in Google Classroom. How much of this do we really want? Can you guys see the sign change, how I have gray stuff up there? It's kind kind of as though I'm trying to somewhat downplay what's in there. Huh. I wonder if once again that's because there's not a lot to really memorize. It's more just seeing how skilled you are with all the stuff we've learned in Chapter 4. P.S. There are two things. P.S. Didn't come out right. There are two things that should have come up in your Google Classroom. One is homework number 31. Thank you for helping me out. One is, I'm seeing you, hold on. One is homework number 31, but what was the other thing? The quest review. Because some of you are going to start doing homework 31 and kind of get bogged down, get overwhelmed, or just really kind of start to hate math more than maybe some of you do. So sad. So I put the review on there so you can go back to maybe some of the beginning. Hey, convert a degree to radian. Oh, that's a thing. I can do that. Reviews. You don't have to write directions or problem details. Oh, I'd rather do that. So I wrote the review up because some of you would be maybe more helpful for you to work on the review once you or when you or if you get stuck in section 4.8. So section 4.8, applications of triangles. We're not spending forever on it. It's literally just today. Why? Well, we got more important things, like a final review to get to. Not getting bogged down in an application section that, once again, you're not necessarily supposed to master this year. You're just kind of getting exposed to yet again. Okay, so in your Google Classroom and in the instructions, let's see how horribly huge, monstrous, disgustingly long this homework is. Oh wait, it's like 10 problems. Okay, I'm going to open it up and look at it. Drama queens and kings. Anyway, coming back. Maybe it's not as bad as you think. Oh my goodness! Wait, where are the notes?
Is this it?
We're just practicing. Do you have your calculators out? Can you guess what mode you should be in for maybe some of these? Does it talk about a sun and a horizon and a shadow and a statue? Can you draw me a picture with a triangle? Go! Let's see if you guys already know what you're doing. What? What are you looking at?
Right triangle problems.
Ah. I was going to come back. I was just see if you guys already know.
Right angles either.
Oh, well, here's the problem. When you're talking about something like a sun, casting a shadow. P.S. Which one seems more like a sun and a shadow problem? The first triangle or the second triangle?
Second.
22.
Wrong.
If you were in a plane, I would say the second.
I thought that was the sun.
If you were in a plane and you were looking out the window,
Yeah.
the sun doesn't usually look horizontally.
Where's the sun?
Where is the sun?
20 degrees.
20 degrees above the horizon.
The horizon is like on the ground, right? You're not up in the air looking down, you're down on the ground looking up to the, well, don't look directly at that, but the
That should
sun.
be on the left or right side.
Ah, good question. So then couldn't this be the shadow that's being cast? If that's the shadow being cast, wouldn't this be the statue and the sun would be up here somewhere? The sun is shining down. There's a statue that's blocking the sunlight to some degree and casting a shadow on the ground. Okay, maybe it takes, sorry, Aiden, I meant to come back.
I just have
Yeah. Okay. Thanks for the reminder, though. I appreciate it. Here's the statue how the sun is trying to shine on and casting a shadow down on the ground. Although, sorry, my sun should probably be way over here, and that's not a 20-degree angle. So I was just trying to show an illustration. Okay, I have a statue casting a shadow that's longer than the statue, and then I have my sun. Are there right triangles? Yes, but are they obvious? No. And that's why I like Nathan being like, you said right triangle problems, and those aren't right triangles. They're not yet. But they are as soon as you realize there's something that's vertically above that does come down. This one, it was the statue that came down at a right angle. Other ones, it could just be north and south versus east and west coming at a right angle. It might not be super obvious where the right angle is. Because the sun's way out in the sky. Shining down the statue that's 12 feet tall. Has anybody figured out, maybe it might help over here to just remind ourselves of what I mean by Pythagorean theorem? Like what you're trying to get, but then how to put it all together. I know. You're pretty confident. What I mean by trig ratios, I mean SOHCAHTOA. So kind of like Griffin's question and how we had to think about, like, hey, what did they give us, and then what trig does that lead to? Nathaniel, that might be the key to what you're trying to figure out. Or like how you're not perfectly connecting the solution. Ah, my cord. Thank you. I can make coffee next week. Okay, so we all unless you hate coffee. What am I supposed to be solving for? What do I have? I have an angle, and I have an opposite. What am I trying to solve for? Y adjacent, Justin, but you're totally right. What does it say? The shadow, and the shadow is on the, wait, the shadow. And the shadow is on the
Ground.
ground. I gave you credit. Got him. Oh, wait, so what trig ratio helps me relate all three of these pieces of information, the two knowns and the one unknown? Nathaniel, does that make sense? I mean, it was longer than 12. But how much longer? You just enjoy guessing. But does the actual, like, getting up precise, does that make sense? We have our opposite, we have our adjacent, we have our angle. Let's tie it all together. So all I have to do is, okay, 2 steps. Just a few of you get lost in the algebra to multiply up that x, right? Multiply up that x and then divide that tangent. Oh, you could, but there's no cotangent button, so you know what I mean? It could be the same thing. Yeah, you're just making it. So I had 12 over tangent of 20. But guys, hold on. What if you plug this in your calculator, like you're rocking it, you knew it was tangent, you knew opposite and adjacent and how to solve, and you're not getting any answer in the multiple choice selections. Like your answers are way off. It doesn't even make sense with the 12, the answers you're getting. Go check your mode. You're probably in radians. All of you guys in degrees, what answer did you get? Don't you have it? 32.97, if you round, and it's feet. Crazy. Is that 20 degrees? 20 degrees, the sun is very low in the sky, so that shadow's good. I don't think I would have guessed 32. I probably would have guessed 25. But still, longer than you would think. So what's the section? Can you use Pythagorean theorem? If you have 2 sides and are looking for a third, sure. But if you have some sort of angle, you either have an angle or you're needing an angle. Well, if you have an angle, you're thinking SOHCAHTOA somehow, and you're trying to put it together. If you're needing an angle, then you're going to be needing to use all of those trig backwards things, where maybe you have sides, and you're trying to somehow set up some sort of inverse trig. I don't know which one, but you're trying to make a ratio of sides that you can then do the inverse trig to get backwards with. Once again, be aware of your mode. And probably, guys, in these practical problems, I'm almost positive you're going to be using degree mode the majority of the time. Oh my goodness! Oh, these really are just examples. What kind of triangle is this going to be? Ground up? Do you see it? Airplane, passenger could be looking straight out the window, and instead it's looking down. You see it? That's why the orientation is going to be 2 towns. You got to be kidding me. 2 towns? Yeah, little dude who could be looking this way, but instead he's looking down and seeing 1 town here and seeing another town here. What? He sees 2 towns. He sees town number 1 that's way out in the distance, and the one way out in the distance has a smaller angle, which is the 28 degrees. And he sees another town that's closer, which made him look further down, steeper down. That's 55. And somehow all we know is a 10, because that's how high the plane is off the ground, 10 kilometers. And somehow we're supposed to be able to figure out how far apart the towns are? That's crazy. All you need to know is what elevation your neck is turning and how high up in the sky you are, and you can know exactly the distances to these towns. But how do you do it? Find that adjacent? Exactly. And then find that adjacent. And all you gotta do is just subtract. Oh, so it's really just two different triangle problems, solving for two different adjacents, and then just saying, hey, what's x2 minus x1? Could these get interesting? They could. But are they still just using triangles? Yes. But does the picture make a difference? Yes. So if you think about the scenario, are you up in the sky looking down? Are you down on the ground looking up? Is it a picture that's just given to you so you just get to kind of look at what it is and how it works? All right, hold on. Section 4.8. Let me go look at that homework and see if I can take off any of these. I know, trying to help. Tonight, Sparkle, you should come out and support. Give me a reason to actually be trying to make your homework easier. Having tons of fun, you mean?
Sure.
Ooh. I probably shouldn't say ooh, because then you guys will stop listening to me. That's good. Oh, I already have narrowed this down a lot. Do you guys notice there are only like, I guess there are 4 evens. I was going to say there are a few. Hey, a shadow of a tree. It looks so much like homework, or like the example. 17 doesn't even have, 1, 6, 9, 13, 17 aren't even word problems. Oh, you guys, I don't know if I can take out anything.
I don't get 17.
Take it out.
You looked at the picture like it said, right? Shown in the figure?
I couldn't find any examples in the book to find the opposite.
Whoa, she doesn't understand we should take it out.
Oh, she took it out.
Justin, check it.
Huh?
Here you go. Took out 17 and made an extra credit. Bye, guys.
Just make sure you have your calculator.
Yeah, definitely make sure you have a calculator. That would be sad otherwise.
On the first page, mark me down for italicized, or not italicizing the book names, like not in time.
Lance?
And she didn't have
Look.
it with her, so she had to sprint to the
One here, and one there. There's another one there. Over there.
Oh, it's
There. There. Put it in quotations.
I didn't know that.
Man, that whole grammar thing comes back to bite me in the butt.
See, why do we even need an English language?
She made you study for a while.
Just ooga booga.
But I didn't
and
have
we'll be
last time.
fine.
Once again. Oh, I have that recorded. Ooga booga. Quote Justin Lin.